Words are important. No matter what job you do, you need to be able to communicate your ideas using words that other people understand. In chemistry, we need to classify matter. That means put it in a box so people know what we're talking about. We're going to talk about atoms, molecules, elements, compounds, and then whether things are pure substances or mixtures. First of all, let's look at atoms and molecules. Atoms are the smallest piece of matter you can get. If you get a piece of paper and tear it up and tear it up and tear it up, eventually, if you could, you'd end up with an atom and you wouldn't be able to tear it up anymore. It's the smallest piece. It's like if the world was made of Lego, it would be one Lego brick. You could have a red one, a blue one, a green one. You can't make it any smaller. Now, molecules are what happens when you take two or more atoms and you bond them together so they're stuck. Like Lego bricks. You take two Lego bricks, a blue and a yellow, you stick them together and you've made something new. Here's an example of a molecule. We've got two orange blocks stuck together. That's like a hydrogen molecule. H2 is two hydrogen atoms stuck together. Over here we've got another molecule with two purples and an orange stuck together. That's like a water molecule with two H's and an O all stuck together. So atoms are just single pieces, single particles of matter, the smallest you can get. You can't divide it anymore. Molecules are where you take two or more of those atoms and stick them together in some combination. That's annoying. And it's perfect. Okay. Sorry, I bumped the tripod. Okay. Next, we're going to talk about elements and compounds. Elements are the different kinds of atoms. In Lego, you've got blue ones and red ones. They're all Lego bricks, but they're different. In chemistry, you've got all of these atoms. They're all atoms, but they're different. These are all the elements. And there's a clue to remind you. It's called the periodic table of the elements. These are all elements. There's some confusion about things like air and water being elements. That's because hundreds of years ago, philosophers thought the world was made of these elements: air, earth, fire, water. But they're not elements. Not in modern science. In modern science, these are the elements, because we know about the atoms. They didn't know about atoms. So you can have elements as all just the same thing. So like all orange bricks. Some of the orange bricks might be stuck together, but they're all orange bricks. So they're all elements. Here's a hydrogen gas molecule. Remember, it's got two atoms stuck together. It's a molecule, but they're both the same. They're both hydrogen. So it's an element. Now, compounds are when you've taken different elements and stuck them together. So you've got atoms of two or more different elements bonded, stuck together. Like a combination of different colored Lego bricks. Or a combination of different elements. Here we've got hydrogen and oxygen. We've got two hydrogens and one oxygen. We call that H2O, water. It's a compound of hydrogen and oxygen. Different elements stuck together. So I also said we'd talk about mixtures and pure substances. A mixture is particles of different substances, stuff, mixed together but not bonded. Like a bag of Lego bricks. When you finish with your Lego, it all goes in the bag. Some of the bricks are stuck together, some of them are separate. You've got different colors. The actual bag is a mixture. We now know that that is an atom because it's all by itself. We know that these are molecules because they're bricks, different atoms stuck together. And we know this one here is actually a compound because it's got different colors stuck together. But in this group of Lego bricks, it's a mixture because they're not all stuck together. It's a mix of this and this and this and this and this and this. Now, if you've got a pure substance, everything in the bag's the same. Particles of the same substance. Bag of Lego pieces that are all the same. And I've got 3 examples. Here's a bag of blue Lego bricks. They're all the same. It's a pure substance. Here's a bag of Lego bricks. We've got 2 oranges and a purple all stuck together, but a whole bag of them. That's a pure substance because each piece in the bag is the same. Here we've got water molecules. We've got oxygen with 2 hydrogens. There's nothing else in there. It's pure. They're all the same thing. So we've got a pure substance, and another pure substance. So how do we separate a mixture? Often chemistry is about separating mixtures because usually when you're making something, you want a pure sample at the end of it. If you're making a medicine, you just want the medicine. You don't want anything else mixed in. So remember, a mixture is not bonded together. It's got pieces, they're just mixed. So you can separate the Lego blocks by color. You can put a red one and a blue one and a red one and a blue one. In chemistry, the pieces are usually too small to use your hands, so we've got to use some lab techniques. Here's a couple. If you've got a mixture of a solid and a liquid, you can filter it. I expect you've seen this done making coffee. When you make coffee, you make a mixture of the coffee grounds and the water, and then you separate out the coffee to take away the coffee grounds. It's a filter. Here's a funnel, and in it is some paper, and in that I've poured a purple liquid with black solid mixed in. I leave it, and the water, the liquid comes out the bottom, the purple liquid at the bottom, and the black solid stays in the filter. That's called filtering. Often you've got a liquid with a solid dissolved in it, or even another liquid dissolved in it. If you want to collect just the solid, you would evaporate the liquid, and all the liquid boils away, and you're left with solid at the bottom, like salt water. If you boil salt water, eventually all the water evaporates as steam and leaves the salt. If you wanted to collect the water, you can collect the vapor, the steam, and turn it back into water. That's called distillation. And how do you know when something is pure? There are tests you can do. You can look up what temperature something should melt at. If it doesn't melt at the temperature that the book says it should melt at, then it's probably got something mixed in with it. And if you want to make sure it's super pure, it'll all melt really quickly at that temperature instead of taking a really long time. If you do college chemistry lab, I expect you'll have to test things to see if you've made them pure enough. So you'll have to check its melting point. Liquids, boiling point, the same thing. If it boils at the right temperature, it's probably the right thing. If it boils in 3 different temperatures, then you've probably got 3 liquids mixed together. Again, you can filter things, and you can test it. If you've got water that you want to test for impurities, you can put chemicals in them and it'll change color, or sometimes it'll form a solid and you can see if there's something in there. So there's chemical tests for purity as well.